Welcome, good afternoon. After lunch break, I tried to get some updates from the ICS, or World of Operation Technology, to you. So let me start. Yeah, just quick agenda, what we gonna look at. But let's start with introduction. What is operational technology, or ICS, Industrial Control Systems? That is like everything which has a connection between the physical part of our world and, let's say, IT systems. So hospitals, for example, then just general industry, manufacturing, trains, logistics, of course, power, electrical power, but also everything, other type of power. And nowadays, cars, they have a lot of operational technology inside, and with electric cars coming more and more popular, also there are a lot of operational technology inside. For example, like what in the recent years very popular, solar power, like you install on your house or your balcony some solar panels. You have a converter where you can then plug in your household devices, and this converter is often connected to the internet. So with an app, you can check how much power you generated during a day, during a month, and so this interconnection also is a bit problematic. We will have a look later on it. Then for electrical cars, these charging terminals you might have seen, they are also all connected by the internet, and then to the power utility, that when you charge, that you is built somewhere. And also that challenging environment, because these terminals, they stay outside. Everybody can almost like go around and open them. So not easy to keep that part secure. Then, of course, smart metering, that is maybe not that new, but in some countries it is a legal requirement that smart metering is being used, maybe in 2 or 3 years or already now. And that also means that every smart meter is connected somehow through sometimes internet, or like a network from the energy company, but somehow they are all interconnected. So these new subsectors often then got like under the radar, or people do not think about. But of course, these highly interconnected devices need also care, or in our case, monitoring. Then also new, we have legal requirements, especially in Germany, is already in place. So in critical infrastructure, you need to have a detection system for detecting an attack. Also logging of everything's going on in your network or in your system, you need to have in place. And Switzerland is following, where you need to have or is an obligation to report an attack. And of course, if you need to report an attack, you first need to be able to detect it. And this all based in operational technology, or like critical infrastructure, not the let's say the general office IT. Then let's have a look at threats, like what is like a problematic, or what is dangerous to the operational technology. You might have, or you might think that would be like a nation state, or now in case of the ongoing war in Ukraine, that out of that maybe some stuff is happening. It is happening, but I wouldn't say is a big threat to our infrastructure, because before all this, like other nation threats, we have a lot of housekeeping or items we can fix ourselves. And for example, remote access, most OT environments, you have somehow a system integrator, so a third-party company, which is like taking care or doing some configuration changes in your OT environment, and nobody is really checking what this system integrator is doing in the network. So if some adversaries or threat actors get access to this system integrator, then he will be able to pivot into your network and do some malicious work or malicious things inside your network. So that is a big issue. We saw already that the system integrators got ransomware, and then it's all the time the big question: what did the I mean, how far did the ransomware crew go, or they just were focusing on the IT of the system integrator? So if you have no if you have no monitoring in place, you're just blind on this type of attacks. Then, of course, configuration errors. OT can have, like I said, these electrical car charging stations. Like, if I be able to connect there my network to the Ethernet port, which is maybe available, what I'm able to see, what I'm able to do there. So maybe if that is not locked down or no firewall in between, I would call that a configuration error. And with monitoring, you also get visibility for this type of things. I added the KNX protocol. This is a protocol used in building automation, where recently the protocol itself got a vulnerability report from CISA, from the United States agency. And actually the protocol is like over secure in a way. So if you purchase a device able to communicate through the KNX protocol, you can set a password for accessing the device, for doing management. Problem is, you can set this password only one time. Even with a hardware reset on the device, you cannot revoke this password. So what is happening in reality is that most implementations, this password is not set, because people are afraid if I lose the password, then I'm not anymore able to manage my devices. But if somebody has access to the network, which should not have access, and figures out that no password is set, he can set all the passwords, and then you have no longer access to your devices. So that is like a typical use case of maybe configuration error or something not done how it should have been. Then, of course, maintaining hardware patching often in OT is simply not possible. For example, firmware updates. If you think in regulatory environments like a hospital, if you just update the firmware of some medical device, you need to recheck. Like, you have to make sure that after the update, the device is working as secure as before. And for that reason, the manufacturer of the device does not allow you to update the device by yourself. Then still a big issue is the missing asset inventory. Like we say, know your network, or what you don't know, you cannot protect. So there are still lots of devices in the network which are just there, but nobody knows. Because in OT, the life cycle is very long, like 10, 15 years. So during this life cycle, slowly devices are added, but maybe the documentation or the asset inventory not been updated. So with that, you end up in the situation that you actually don't know anymore what is in your network. And like real threats where we saw a little bit in the last year, like Colonial Pipeline in the US, where they had to shut down the whole oil, or how you call it, the oil refining system. That was not actually because malware went into OT environment. It was simply because the billing system did not get the data anymore from the OT side, because they had to shut down the interconnection between IT and OT. But it is a threat. We are afraid of that when ransomware will also go into OT environments. Another, like something new, or which is starting slowly in OT environments, is encryption. You can encrypt communication, which nowadays mostly is still clear text. It is available for most of the protocols. So either you do TLS encryption with certificates or with passwords. But the problem here is that it impacts the availability or the that you can keep control over your system. And recent studies showed that you are able, with just using the system internal functionality, to set up the system in such a way that you can like trigger one bit, and then the whole system gets like goes into a state where it is not doing the task anymore which it should. And that's why it's called like Deadman's PLC, or cyber extortion for OT. So just using this built-in functionality, you are able to set up the system in a way, then call the company and say, hey, we locked your system down. If you do something or if you don't pay, then we just shut it off. So in that perspective, I think encryption will not be widely used. Of course, there are use cases for it. For example, if you need to transfer data over the internet, but then you can also use widely available techniques we know from IT, like VPN or just encryption for the data which you send from one place to the other. Endpoint protection, I think in the IT security world, is like the big, how you say, thing at the moment. So if you don't have endpoint protection, you lose a lot of visibility, because especially in the Windows world, when something is happening, it starts first on the endpoint. The user is opening something, the user is clicking on something, and with these agents running on the host, you can detect this type of behavior. In OT, on the other side, on devices like you see on the picture, which actually has like an Arduino microcontroller in it, you cannot install an agent because you do not have access to the operating system directly. So there is not possible to have this visibility, what is happening on the host or on this OT device directly. Some devices, they support security logs. So if configuration changes are made, you can read out these logs and process it in a central place. Often engineering stations are these, how you say, hosts where you configure OT devices. They are also running on Windows, or where operator are controlling a process. This type of host, there I would say safe to use an agent. Is these endpoint protection agents, they are quite lightweight. So it's not like some years ago where you have antivirus, which then suddenly is taking like 20-30% of your CPU to analyze something. These agents use just a few percent of the CPU and very little RAM. So it's not interfering with the other services which are running on a OT Windows host. So what's next? So we have the current state, shortly looked at, and I would say preventive measures are still king. This the way to do, the way to go, and way to do. So, for example, train your OT engineers. They know the process very well. They know the environment very well, but sometimes they are not familiar with the network or what is happening on the network, or even what is security. It can start with like they know all the time what is DNS, but they never dare really to ask what that actually is. So starting to train your engineers into the direction of what is security, IT or OT security, how the network is working, that helps a lot. That these people get the understanding, like what they can help in their everyday's work to improve security. Then network segmentation. We see still a lot of networks which are flat networks, meaning no segmentation at all, and that makes it for an attacker very easy to look around in your network and see what where he needs to go. Access control, of course, like I said, from the remote support. Often this is still like to the system integrator. You have a 24/7 VPN, so means the VPN is all the time on. Nobody is checking who is doing what over this VPN connection, and that is also kind of opening doors for misuse. Then, of course, system integrator coming to your place. They come with their own laptops, and because OT software is difficult to maintain, they have maybe, you know, like the last 20 version of a software installed on their laptop. And then, of course, in the evening, they want to do some private stuff on the laptop. So these laptops are often with stealer malware or other malware infected. So there it is really important that we can provide them workstation from the company, which we know it is clean. Last but not least, turn login on where it is available. Also, this people forget to do it, because once the process is running, you don't care anymore because it is running how it should. But the security needs some extra work or extra steps to do. So logging is one of this type. Then SOCs, as Security Operations Center integration, we see also that demand is getting stronger. There maybe we can add that if you run a SOC, or if you're looking for a SOC and you want that they control your OT part, then awareness and the appropriate tooling is important. Because different to IT, in OT you cannot just turn off a host or contain a host, like disconnect it from the network, if you are really not 100% sure what this host is doing. Otherwise, you might just interrupt the whole process. So imagine the power distribution of PISA. You say, oh, there's on a host, there's something strange going on. You turn it off, and then operators lose visibility what is going on in the power grid, and that eventually lead to a shutdown of the power grid because of a safety reason. You can add or you can have some quick wins in your OT SOC integration, which might be that you in the beginning you do not need to get a full OT protocol passing. You can start with just looking in the network what is going on, who is talking to whom, which protocols are used. For that you don't need to have deep insights into the network. Nevertheless, at the end, I do think it is still needed to have this visibility, because critical process values you might need to check also from security side. Outlook, a bit what I just said, full pickup for critical processes, I mean full pickup analysis of critical processes. And if you cannot do that, NetFlow already helps a lot to get the visibility. Also in OT networks, maybe also easier to implement when you have slow or low bandwidth to get that data out of your environment. So there still possibility to get this visibility. And what we see as well is like simple and it works, meaning that like old OT protocols like Modbus TCP, which let's say 3 years ago you would have asked me, I would have said, oh no, Modbus TCP will not be used anymore. We see that is now having a revival in all types of products, like this PLC I showed you before with the Arduino inside. It is actually able to talk Modbus TCP out of the box, and we know it's functioning, so that's why people start to use it, because it's reliable. This is helping us from the monitoring security side, because the protocol is also easy to understand in the in monitoring, and with that we get the visibility. With that, I'm at the end. I hope thank you for listening, and I wish you a nice afternoon.
Thank you, Martin, for connecting with us. Any questions?